Hi there, and a very warm welcome to this week's Quickish tip. This week it's another color workflow centered one, though it's not about ACES, but AgX. If you're familiar with Blender, you might have heard of the filmic workflow that was created by Troy James Sobotka. So he continued his research on tone mappers to be able to manage color in a way that film or our own eyes would perceive them. In contrast to ACES, which is a color space on its own with a tone mapper at the end, AgX is just a tone mapper to give us nice colors. And it's very similar to the ACES sRGB tone mapper that we all know and love. As I'm standing on the shoulders of giants, here's a couple of shout-outs, of course to Troy James Sobotka for creating all of this in the first place, and to Professor Klein, who was constantly nagging, trying to tell me about the AgX workflow on my ACES workflow tutorials. I won't go into depth about the color science behind AgX. If you want to know more about this, there's a really great 3-part video series from Riley Brown who goes into depth about the background and color science of this whole thing. In the following, I will show you how to use it inside of Octane in Cinema 4D, and if you stick with me to the end, I'll even show you some fusion magic and how to get it done there. If you like what I do and want to support me making tutorials for everyone, you might want to head over to my Patreon and check it out. The link is down in the description below. And now, without further ado, let's jump into the juicy bits. Welcome to 3D land. So the first question to answer is, why even use AgX? Isn't the ACES tone mapper enough? And yes, while the ACES tone mapper is worlds better than the standard sRGB workflow that we had for years, the AgX tone mapper can actually improve on some things in a couple of cases where the ACES tone mapper can't deal with very high saturation levels. So let's have a look at our diamond. I can't seem to get around diamond somehow. So let's have a look at our diamond here. So this is a realistically modeled and shaded diamond. If you're interested how to do that, I made a tutorial series as well, so you can click on the upper right corner on this video on the info box to learn more. But now back to topic, and this is about the colors here. So you can see we have some really saturated colors, such as this pink and this blue, but also the reddish tones here. Now, if you've watched some older tutorials about ACES from me, you might say, well, that's not a problem, we can get rid of them with ACES and the nice tone mapping that it provides. So let's actually try that and go to the one-click ACES tone mapping, also info box link in the upper right corner to that video, and let's click the workflow here. And you can see the gradation on the orange and red parts is a lot better. But still the saturation of the pink levels here is out of scope. So while ACES can deal with a huge variety of different scenes and handle them well, there's some very fringe cases that it can't handle, and this is one of them. Let me show you what AgX can do by disabling ACES and then go to AgX. And you can see now the colors are not oversaturated anymore and blend right in very nicely. What you also might have noticed is that the AgX profile isn't as contrasty as the ACES one. So if we go back to sRGB, it basically looks pretty much the same as the raw sRGB, but with the ACES you have a contrast increase. So the ACES tone mapper always means more contrast. Let me go back and forth between the ACES and the AgX so you can see the difference in the handling of the very saturated colors here. And of course, if you lack contrast, you can add that later in post. So while I was doing that, I guess a lot of you had the question in mind, where did I get my AgX profile from? So why is it here inside of Octane? Well, basically it's something that comes in with OpenColor.io, and if you know the old workflow, not the one single click workflow, but the old one, where you can get OpenColor.io ACES files in there, it's basically the same. So if we go to settings and to color management, you can load whatever OpenColor.io profiles there are. So I downloaded the one from James Sobotka's Github and unpacked it to where I store all my OpenColor.io data. It can be any folder on your system. So once you unpacked it, you link it with the button and then go and select the config OpenColorIO file here. And once you've done that, you have it implemented into Octane. There's one more last step, and this is in the camera imager. So let's go there and go there to OpenColorIO. And if you loaded the profile correctly, you're greeted with the whole shebang of new settings here. Let me give this a little bit more room. Here we go. So if we roll this down one more time, you can see there are a lot of options, but only a few ones are for the display you're using. So basically, let's go here and switch back to our OpenColorIO. So this is linked to this here. And now we can see what we have here. So for example, I use an sRGB display, so I can use this one here, but this is very low contrast. So what I'm opting for is the BT1886 Appearance Punchy, and this gives us a little bit more contrast here. So what is BT1886? Basically, it's the same color space as Rec 709. Since most displays are sRGB related and Rec 709 has also the same space as sRGB, you can interchange those. What you shouldn't do is go with any other color space that isn't sRGB related, such as P3, because that will mess up your colors. But then again, a lot of things have been done with a shield of creative freedom, and if it looks good, it's never wrong. So do as you please. I will stick with my punchy one. Here we go. The keen-eyed among you might have spotted it, and yes, the Cornell box is back. Now this time with a bit of an abomination of a scene, because we established that ACES cannot deal with highly saturated colors. I made this scene here. So let's go over it real quick. We have our 3 light sources. So basically the desk lamp here is green, the ceiling light is yellow, and then we have a red light, and this was our reading light before. So if we look at our main path again, you can see a couple of flaws here. Basically, all the light sources are deeply saturated, so the red light is completely red, and that makes it look as if it wasn't emitting any light. So the light that comes closest to the look of actually emitting light is the ceiling light. And the green light back here you cannot even notice, because it's also very saturated, and between the green wall and the brightly green lit backside of the wall here, it doesn't stand out at all. Now when I turn the one-click ACES solution, this gets a whole lot better. So let's do this. And we can see now we have the lights actually showing up instead of being a red, green or yellow mess. Also what you see is that the ball in the foreground actually has reflections, which was impossible to detect before. So this example, believe it or not, is not as extreme as the diamond one, and ACES actually handles pretty well. So let's see what AgX actually can do to the scene. And even though ACES handled well, AgX gives us even more gradation and nice fine detail out of the scene. Let me guide your attention to this spot where the red light is lighting up the red wall. Now for a renderer, this is a very complicated situation because both the wall and the light is red. And if we go back to our sRGB workflow, you can see this doesn't work at all. And while ACES behaves a little bit better, you can see here there's at least some differentiation going on between the back wall and the lit spot from the light. The AgX is actually doing it a little bit better. As I said, those are very extreme cases, and if you're considerate in making your materials and lights, you should never run in such situations. But it's better to know how to get out of one if you're getting into it. The other thing I heard a lot in the past about was that ACES was making the scene very contrasty and therefore rather dark, and you had to expose accordingly to get rid of the too dark areas. And as we've seen with our diamond, so if I turn off ACES, this is not a good example. If I now go from my unaltered sRGB to the AgX, you can see that the contrast roughly stays the same. So basically, if you're having a great sRGB workflow already, you can implement AgX much better than ACES, because ACES has a different look to it and you have to adjust your curves, for example, in your compositing package. Alright, back to our diamond scene, because this renders faster and therefore is less time consuming. So let's get going with the output settings. There are 3 different output settings here. So let's open the Octane settings. If they're not there, of course, we need to engage Octane as a render engine here, and then go to the settings here. If you would change nothing here, you would get the sRGB look, which we aren't after. We want the AgX look here. Or at least we want to get somewhere with it in the comp part. So you can already guess where this is going, linear workflow and such. But first of all, let's talk about baking out this look so you don't have to do any comp and anything. So when we go to our color space, there is this open color IO here, and once we click it, we have the option to choose a color space from the loaded open color IO file. So we go to color spaces, imaginary, and then to AgX base. And once we've selected that, there's another drop down here where we can choose the punchy look, for example. Last but not least, what you have to do is set the HDR to LDR 8-bit in order to get the right brightness in the render. So let's render and see what it looks like. And yes, we are getting the same image as we did in our live viewer. And this is always a good sign that we did something right. Next, since AgX is not a color space, we can go with a linear sRGB workflow. And you would do it like this. You would set this to float 32-bit and this to linear sRGB and then render it out. But we could also use the ACES color space and therefore parts of the ACES workflow. Hear me out on that. So rendering is basically an investment. So every time you render, you need some resources to get your pictures out. Mainly that's electricity. So as electricity is gotten a lot more expensive, you don't want to render out everything a million times. So when I render out stuff, I like to have it future-proof so I can just use the renders instead of re-rendering. And rendering something in a bigger color space is more future-proof than rendering something in a small color space. So since ACES is a bigger color space, you're making your renders more future-proof, and if you know how to deal with it, you don't have any disadvantages. You can get your sRGB look back from the ACES files as well if you are keen on doing so. So let's set this up for ACES by going to the drop-down here and going with ACES CG. Then let's go through the output setting one more time. So first enable it, then we want to paste in our render tokens. You can also choose a path manually if you want. I always render EXR Octane 16-bit and then DWAB, and then I want to render my beauty and don't want to render multi-layer files as always. Now that we've set this up, let's render this. Here we go. And now you see that the file is looking kind of strange, and this is because it renders out the raw colors. It's not baked in, so we don't see what we had in the live viewer. This is also important to know. And now, as promised, let's jump over to Fusion Studio. Welcome to Fusion Land. Let me just drag and drop our file that we just rendered and display it. Now, this looks a little bit contrasty, and this is because it's linear ACES CG. To display it in a right way, we need to go to the LUT section up here and go to the OpenColor.io view, and then also click Edit to get in our OpenColor.io. Click Browse, and then go and look at our list here. What we could do is go the traditional ACES route and load our ACES OpenColor.io file here and get the tone mapper from there. But since we are engaged in an AgX workflow, we want to go with the AgX OpenColor.io file here. Now we need to choose our source space and output space. For the source space, ideally what you want to choose is ACES. But in the config here, there's no ACES profile. We could work around that by going to the node tree, add a OpenColor.io node and go from ACES CG to linear sRGB, and then from there back to AgX. But this is a lot of hassle, so I did some research and found some other ways to do that. So there's this guy Genco Üneys who wrote his own branch of the AgX OpenColor.io. So I downloaded the Pixel Manager master from his GitHub, and in there's also a config OpenColor.io. And once you choose that one, we have access to the ACES color spaces. Now, I don't know what it is, but people love to name things twice. So the AP0 here is the big ACES space, so the 2065-1, and the AP1 is the smaller ACES CG color space. And since we are rendered in the ACES CG color space, we need to choose this one. And then for the output space, we just scroll down until the AgX comes up. Here we go. And then close the window here. Now, unfortunately, this AgX doesn't have the punchy look, but we can create our own punchy look by getting into color correction, since we are in comp anyways. So what we want to do is click on the file we just dragged in and hit Ctrl space and type in CC enter. And this brings up a color correction node. Let's display the color correct node here, and let's go to the gamma and get it down a little bit. So maybe 0.75. And then go to the gain and up that a little bit, 0.25 maybe. And there's our punch coming back. And you can basically also see we have those subtle colors here that are not oversaturated and look very nice. Now, before we bring this tutorial to a close, let me invite you to a small session of chart time. Since this is a lot of back and forth with color spaces and transforms, I made this small graphic to get your brain wrapped around this, hopefully. In this slide, it is labeled 3D software, but it can also be a compositor. So to break everything down in a very easy way is that we have always an input, something where colors are generated in rendering, for example, or some image sequences, and then we have an output. And then when we do something to it, we also want to look at it in the right way. So right now in the compositing, we have native ACES files going in. Then we have the compositor doing its magic. And while we are doing it, we are looking at our display through a view transform. So our view transform is giving us the image information that AgX provides, but our comp itself is still in ACES CG right now. And if you output your files, you can choose whether to leave it in your native color profile, meaning ACES CG right now, or if you transform it to your, for example, display color space, so you can upload it to YouTube and everything can see the colors you want them to see. So in an even more broken down version of this, actually what OpenColor.io is doing is taking an input and you define what color space the input is, and then you define what color space you want as an output, and then it's doing its magic, transforming the color space from one to the other. Now the color space cannot only be a simple transform, it can also inherit a tone mapper. For example, with ACES, the ACES to sRGB output or the ACES to Rec 709 output are tone mappers. And this is where you get the nice color rendition from, and also maybe the too punchy contrast that some, including me, complained about in the beginning when I started using ACES. And AgX is no different than the ACES to sRGB tone mapper. It just has different tone mapping parameters inside that makes the input look more filmic or perceptual, like our eyes see the world. Okay, back to comp. Alright, back to Fusion. So of course this is the comp stage and you can do a lot more to your comp, for example adding glows, adding vignette and even more color correction, for example. But for the sake of not making the tutorial too long, let's say we are satisfied with our result here and we want to save that out. So what we need here is an OpenColor.io, which we need to transform our view, because as I just said, the LUT here is transforming our view just for the display. When we would save out this right now, the output would look like this. And we want to save this look with our AgX transform. So let's go to this node here and Ctrl space and hit OpenColor.io, the second node here. Here we go. And then basically do the same thing as we did with our LUT. So go to our Pixel Manager Master and choose the config OpenColor.io here. Go to the source space, AP1, and output space, scroll down to our AgX base. So once we view that, we get our AgX applied twice, so we want to turn off the LUT here, and then go ahead, select the node, again Ctrl space, and then hit SV for save. Let us save that on the desktop and call that, for example, AgX.tiff. Enter. And that sets our output format automatically. Last but not least, what you want to do is go with an 8 or 16-bit integer format here, because otherwise it would save out 32-bit files, which you don't need anymore because you have the color transform already applied. So if you want to do even more corrections, you can go with a 16-bit. If you are good and want to just get this out and done with, you are good with 8-bit. That's what I always do because I do all my corrections in the comp before. Last but not least, we don't need an alpha for this sequence here because there's no alpha in it. And then we can hit render and then render out frame 0 only, and this then would conclude our AgX workflow. Alright, hopefully that gave you a little insight into my world of colors and workflows. I know that there's a lot of things I didn't touch on in this small quickish tip, but you can get a lot of knowledge in my other tutorials that surround the ACES workflow and the comp workflows. Whether I use AgX or ACES is a case-by-case thing, so usually ACES works fine, but if I have problems with colors, such as with my diamond renders, I switched to AgX to make them look just a little bit more pretty. And if you're used to ACES like I am, with a little bit of comp magic you can get the contrast exactly the same as it comes out of the ACES sRGB tone mapper. So you have basically the same look, but with a little bit more headroom when it comes to saturated colors. And I would say this concludes this tutorial. So if you're still with me, thank you very much for staying that long. Huge thanks to my Patreons who support me and by doing so making stuff like this tutorial possible. It's my huge dream to shift my income more to a YouTube and training-centric one. If you want to support me or feel empathy with me, you can do so by becoming a Patreon. The link is down in the description. Or for example, booking a training with me where I can teach you all about materials, rendering and so on. Last but not least, a small anecdote if you wondered what AgX even means. In the periodic table, Ag is the name for argentum, silver. And with the X it refers back to the ingredients of a film emulsion. And I found it funny that basically AgX has the hidden meaning of silver in it when my name is Silverwing on the internet. So maybe it's a fitting tone mapper for my work. Let's see. And with that, I wish you a good start into the week. Until next week, and happy tone mapping. Bye.